Okay, you may have heard me in another video talk about these things doing the chair flip or doing an inversion. What this means is that you can see this equilibrium form that's kind of right here in the middle. That if I've got one form of cyclohexane, what it does is it goes through equilibrium and it flips from one of these chairs to the other. Notice that this is a flip. It's not a rotation. We don't flip it over. What ends up happening is the bonds here, they can pop back and forth. Okay? I'll show you this with a model in class. Okay? What happens when these things invert? You don't have to flip it. This is just some angle energy. It just causes things to pop up and down, okay, in the middle of these things. It's kind of like a double jointed molecule right here. And these particular forms, they flip. They don't flip per se, like do a flip, like American Ninja Warrior type flip. What these are just inversions. This is like a molecule. Remember, these solids, they're vibrating. When they vibrate, they kind of do this kind of thing. They kind of wobble like a bowl full of jelly, okay? So it's Santa Claus's belly, essentially. But when these things jiggle like that, okay, you can get the bonds, if they're pointing up, they can point down, and that causes a sort of a chain reaction through the system, which inverts the stereochemistry of these things. So if there's no energetic barriers here, there's about a 50-50 ratio of chair 1 versus chair 2. Okay? But this only happens if you've got enough energy nearby. Why is that the case? Well, let me show you. All right? Here's a chair cyclohexane, and what happens to it? If it starts over here, okay, there's enough energy in the environment. Remember, this thing's vibrating and wiggling. It moves up. And at a certain point, you get a half chair. Okay, this is the beginning of that inversion. Once you get to the half chair, everything is parallel until it pops back down in that lower position. At that top chair, it could do two things. It can either pop back to its more stable chair formation, or it can flip down, and when that happens, I get the twist. Okay? So you do the twist, that's what happens there. You get a twist, and that twist then organizes itself into a little bit higher energy. That's the boat form. Remember, these are twist chairs. They're a little bit lower in energy than the boat. You can see there's not a big energetic difference here between these two. Okay? So the boat, basically, it's going from here over. Once you have enough energy to do this type of transition, then it's flipping back and forth pretty easily between these two forms. Okay? And then at one point, you've got enough energy where it's going to come up, and then it gets at a half chair again, and then it goes down and completes the flip. Notice that this didn't involve any taking the molecule and rotating upside down. Don't think of it that way. That's the easiest way to make mistakes on a quiz or a test. Think of it as an energetic inversion of the bonds. Okay? My models will be able to show you that this is actually pretty easy. I want you to actually get your hands on these things and play with them. Tactile sensation will help you remember how these things invert and how they pop. Notice over here, that one over here is pointing downwards. Where is one pointing on the other chair? It's pointing up. Everything is the opposite when you do one of these chair inversions. Okay, 6 is pointing up, now 6 is pointing down. 5 is pointing down, 4 is pointing up. That type of thing. Alright? If there are substituents here, say there is a chlorine that's in the axial position on 1, where's that going to be when this inverts? It's going to be in the equatorial position. Everything that's axial will be equatorial. Everything that's equatorial will end up being axial. So over here, if this is axial, it's going to be equatorial on the other side. If this is equatorial over here, when this inverts, it's going to be in the axial position on the other carbon. Okay? All right. So here we go, right here at the bottom. X axial, Y equatorial, and when there's a chair inversion, this says it's very fast. I use caution to use that term because it's only very fast if X and Y are the same atoms. If they're not the same atoms, there's going to be some kind of steric consequence, and we'll get into that here in a second. But if these two things are equal, say this is chlorine, that's chlorine, there's no difference between the two. It's going to be very fast, and it's going to be a 50% concentration of this guy and a 50% concentration of that one. Okay?